Hello, students. So far, we discuss the adders and subtractor. Last class, we discuss the full adder and full subtractor. Okay, the circuit will add two numbers. Likewise, full adder will add three numbers. Likewise, we have half subtractor will subtract two numbers. Full subtractor will subtract three numbers, and realization and the circuits, how to design the circuit we saw last class. Today we are going to see discuss decoder. Decoder and encoder is a combinational circuit which accepts certain inputs, okay, and produce uh, output. For example, decoder will accept yeah, n number of inputs and 2 power n outputs. For example, if you have one input in decoder, the output is 2. 2 output will come. If the input is 1, the output is 2. Suppose if the input is 2, the output is 4 inputs output. So likewise decoder is a circuit will which use out of many inputs, out of many output input, it generate number 2 power n outputs. Let us see the definition. Decoder is a combinational circuit that has n inputs line and maximum of 2 power n output line. That is double of n. One of those output will be active high based on the combination of the inputs present when the decoder is enabled. That means the decoder detect a particular code at a time. Only one input line is activated for simplicity. The produced 2 power n bit output code is equivalent to the binary information. So this is a block diagram of decoder, how would be the inputs and what the output is to power outputs. Let us see. There are various type of decoder which are as follows. 2 to 4 line decoder. That is two output, okay, two input and four outputs. That is for one input, it is double, two in output. For another input, double. So simply 2 to 4 decoder. In the 2 to 4 line decoder, there is total number of three inputs, that is A0, A1 and E. For four output, that is Y0, 1, 2 and 3. For each combination inputs, when the enable E, whenever E is enabled to 1, the decoder will function. Okay, according to the suppose 0, 0 means the Y0 will be executed, that is the output will come. Likewise 0, 1 means y1 will be activated. Likewise 0, 1, 0 means y2 is enabled. Like 1, 1 means y3 will be enabled, because out of many only one output can be activated using E. So on those four output will be one. The block diagram of the truth table of the 2 to 4 line decoder is given below. This is the block diagram 2 to 4 decoder. So for example, you have enabled E is simply like on, off, and if it is on, 111 means all decoder will function, otherwise not function. So it have two inputs 0, 1, A1, A0 and A1. First is 0 means it is not function, all output is 0. Suppose it is enabled to 1, the output is A0 is 0, 0, A0, 0, A1 is 0. So output is 0. Because this is 0, the Y0 will be enabled. Likewise, if you have a 0, 1, 0, E enabled is enabled, it is already on. Suppose 0, 1 means 0, 1 is 1. Y1 will be activated. Out of many output, Y1 only enabled. That is high. Likewise 1 0 it is 2, so y2 is enabled. 1 1 means 3, so y3 is enabled. Out of many outputs, only one generated according to the number. So this is your realization expression term y0, y2 and y3 as follows. Y3 equal to E1. How y3 means what would be the input, that is E equal to 1, A1 equal to 1, A0 equal to, and A0 equal to A0. So likewise you have y2. So this is a logic diagram of your uh, logical circuit of the computer. A0, A1 and E. E is connected to all AND gate. According to the NOT gate, the Y3 will come, Y2, 1, Y1, Y0 will come according to the input. If it is 0, 0, Y1, Y0 will be worked. If it is 0, 1, Y1 will be worked. Likewise, 1, 1 means Y3 will be worked. That is, the output is Y3. So this is a block diagram of your 2 to 4 decoder. You have 3 to 8, that is a 3 variable, a 3 to 8 decoder line. Okay, it have 3 inputs, A1, A2, A0, A1, A2, and 0 to 7 output. For A0, there is two output, Y0, Y1. For A1, 2 output. Sorry, 3, 2 power 3. No. For A0, 0, Y0, 1, 2. For A1, 2, 3, 4. For A2, 4, 5, 6, 7. Like this for 3 inputs and 8 outputs. So this is a block diagram. That is a truth table for this 3 to 8 decoder lines. Okay. So this is your code is generated. That is the logical expression of your y0, y1, y2 up to y7 as follows. What is y3? Y0 is y0, a0, a dash, and a1 dash, a2 dash. 0 means like this. This is your expression, realization expression. Y1 up to y7. So this is your circuit. Okay, this is your circuit for this realization of y0 to y7. So this is your decoder. What is encoder? Encoder is opposite of your decoder. Encoder is a combination circuit that perform reserve operation of decoder. It has maximum of 2 power n input line and n output line. It will produce binary code equivalent to the input, which is the active high. Therefore, the encoder encode 2 power n input line with n bits. It optional to present the enabled signal in the encoder. So it is opposite of your decoder. So it have, if you have 2 output means the input is 1, 2, 3, 4. Okay. Likewise, if the output is 3, input is 8 input. Likewise, come to the 4 to line 4 to 2 4 to 2 line encoder. You have 4 output, 0, 2, 3. Output is 2. That is the reverse of your decoder. For example, you see you have 1, 0, 0, 0. So this y3 means 0 1 0 0 means so this is what 4 to 2 line encoder, and this is the logic diagram, logical circuit for the above expression of your encoder. So y3 plus y2, y3 plus y1. So this is well designed using OR gate, two OR gates. Okay. Okay, come to your 8 to 3 line encoder. 8 in encoder, 8 input is there. So only 3 output is there. So this is your book table for your 8 inputs. 0 to 7 inputs, 0 to 7 inputs. Output is 3. So output is 3. 0 0 0 means 0 0 0. This is 0. Y0 means Y0. All in output is 0. For Y1 means 1. 0 will be, that is so only Y1 will be activated. Likewise, you have a Y7 means all will be enabled. That is 1 1 1. So it is a truth table. Then you have for this expression, this is a design logical circuit for the expression of your 8 to 3 line encoder.